Yep. I think we can begin because a lot of engineers have urgent job to do, and they are interested to watch again the video of your session today. So I think we can begin now.
Okay, no worries. So hopefully everybody has WaterGEMS open and is ready to go, and I'll share my screen here. So the one that we want is obviously close down the one from yesterday, and then open up, and in the same folder as all the ones yesterday, water quality .wtg. All right, so what we're going to do is several different types of water quality. So the first one we're going to do is TDS, total dissolved solids, and what we're going to do is essentially just put that into the system, and then that's going to get kind of washed around. So we're just getting that. It doesn't grow or decay. That's just going to go out throughout the system, and we can watch that go around. And then the second one we'll do is chlorine, which of course will decay. So we'll watch that come out of the reservoirs and then how it affects the tanks. And then we're also going to do an age run and see how the water is within the tanks and throughout the rest of the system. So that's the plan, and you'll see that water quality is actually quite easy to use. It's this type of water quality, what we call constituent water quality, is pretty quick to set up and pretty easy to to set up and run. Okay, so let's get started. The water quality kind of setup and everything is in the alternatives. So go to alternatives, and you'll find that constituent has its own. Water quality has its own alternative, and that alternative is constituent. So what we're going to do is from default constituent, right click, and we'll say new child alternative, which I'm going to rename TDS 300. So once you've created TDS 300, double click on it to open up the constituent dialog box. And the constituent we want here, we haven't created yet. So what we need to do is go to the ellipsis to open up the constituents, where we can create all of the different things that we may want to run around the system. So go and select new and TDS, total dissolved solids. So create TDS. And then, as I mentioned, this one is just going to float around the system. So the reaction order is 1 with a reaction rate of 0, and then the wall reaction 0 and 0. So basically, this does not react within the system. All it does is just follow the system around with obviously the flow. Okay, so close that down now that we've created it, and of course select TDS from the drop down. Now, of course, we need to put our initial concentrations or our starting values into reservoirs, tanks, and sometimes junctions. So if you come over to the reservoir tab and then scroll all the way to the right, you'll find the concentration initial in milligrams per litre. And for reservoir 1, it's going to be 250. And reservoir 3 is 600. So as you can see, the water out of reservoir 3 down the bottom there with the pump is much worse than reservoir 1, and we'll see that as we follow the color coding around. As for the tanks, let's go over to the tank tab, and again scroll over to the far right where you find concentration initial, and these are both 300. The concentration initial in the reservoir, it's going to continually put out that concentration as you pump water or gravity feed water out of your reservoir. Whereas, of course, the tank is fed by the reservoirs, and so this is just our initial starting point, and then it will settle itself out. Okay, so that's all we need to do as far as creating and setting up the constituent alternative. What we need to do, though, is also go and set up our calculation options to run a constituent analysis instead of just a hydraulic analysis. And that's important because if you don't swap it over, you won't get any results at all. So go up and you'll find under the home, you'll get options. You go ahead and select calculation options. And underneath the steady state EPS, just go ahead and click new, and then rename it to constituent or water quality 288. So constituent 288 hours. Obviously, we're going to run it for 288 hours so that it has time for the system to settle out and the concentrations to level. So once you've created it and renamed it, open up the properties. And the main thing is to swap the calculation type. So from hydraulics only, we want to select constituent, of course. See, once you change it to constituent, you get the start times change down here. It's now an extended period simulation. And of course, we need to change the duration from 24 to 288. So that's all we need to do. So just constituent and 288, and then you can close it down. And close down your calculation options. And then head over to the scenarios tab. So from base to right click, and then we'll take a new child. And this one's going to be called TDS 300. Okay, so open up the properties of TDS 300, and as we know, we need to change the constituent to the one we just created. We also need to change the steady state EPS to the constituent 288 hours. If you don't change that, it will just run the hydraulics and everything will look fine, except that you won't have any water quality results. You'll only have standard results. Okay, so once that's done and you've made current TDS 300, you can compute. Hopefully you didn't get any problems with your calculation summary, so you can close that down. Now, the best way, I think, to view results for this particular water quality is via the color coding and the time browser. So firstly, we'll set up the color coding. So over to element symbology. And on the pipe, on the top one here, we'll right click and we'll take new color coding. The field name is going to be concentration calculated. And then you can calculate the range. And then all you need to do is hit the third button along here, initialize. And then you can apply and say OK. Okay, now up in the compute area, you'll find the times, and that's the time browser. So you go and open up the time browser, and then you can use this slider to make it faster and slower, but basically you want to hit play and then watch those concentrations vary throughout. So you can see reservoir 3 down the bottom here, that's the one with the 600 concentration, the very high. So when the pump turns on, of course, it pumps all of that 600 concentration out into this system. And then as the pump turns off, it's fed by reservoir 1, and then back it goes. And you can see that it affects all the way up to tank 2 here when reservoir 3 starts to pump. So I'll just give you a minute to watch that through, and you can change the speed if you want to make it go faster or slower or whatever. Okay, well, mine's finished. So probably move on to the next step. So similarly, if you wanted to look at a specific result, so maybe one of these ones down in the bottom area here, maybe say junction 28, you can graph it the same way that you graph everything else. So it's just a matter of right-clicking and graph. But instead of hydraulic grade, you can untick that, and you'll find that water quality has its own results section here. And in there, you'll find concentration calculated. So once you've selected it, go OK, and you can check the concentration of junction 28 or whichever one you picked. And of course, you can see that as it gets pumped in with water from reservoir 3, it obviously climbs up to the 600 mark and then settles back down to 250 when the pump is off. So quite variable up and down because of that pump pumping that dirty water in. Okay, well that was the TDS, and we can now move on to chlorine, because that one's, chlorine's probably more interesting, particularly because it's so commonly used, but also it's got a decay rate and a wall reaction rate, so it's a bit more complicated, but also very easy to set up at the same time. So back to the alternatives, and then from the default constituent, I'm going to take a second new child, which I'm going to rename chlorine. So once you've named it chlorine, you can open it up and we'll do the same thing again. We'll go to the ellipsis and we'll create a new one. And of course, it's called chlorine. So this time we are going to enter some reaction rates. So the reaction order is 1. The bulk reaction rate is minus 0.3. So minus 0.3, and the reason it's minus is because, of course, chlorine decays over time. So if you were modeling something that has growth over time, then you would put in a positive value. Of course, chlorine does not grow, it decays, so we need negative. So that's very important. Otherwise, your chlorine residuals are going to continually go up instead of down. Same with the wall reaction. So we need to change it to first order. This is also negative. And this one's minus 0.305. Okay, so by the way, in case anyone's wondering how you get these values, you need to test for those. So you can do jar tests and get those, and of course you can calibrate it within WaterGEMS as well by pulling in SCADA data and then of course comparing it and seeing whether you're too high or too low. So all right, so close that down and of course change the constituent to chlorine. And just like the TDS, we need to go and put initial concentrations in. So this time there's no tank initial concentration, it's only reservoir. And if you scroll across, the concentration is 1 for both reservoirs. So we're sending out the water with a chlorine residual of 1 part per million or 1 milligram per litre. Okay, once you've done that, close it down, and of course we need a new scenario to put it in. So from base, take a new child called chlorine. Go ahead and open it up and change your constituent, and then make sure you change the calculation options as well. And then you can make it current and run it. Okay, so the problem here is that we've got our chlorine concentration color coding set up, but it's set up for a scale of 0 to 600. Of course, chlorine is on a scale of 0 to 1. So we don't. We could make a new one, or we can just go to element symbology and open up concentration calculated, and then just recalculate the range. Of course, it's 0 to 1, and then just reinitialize. And once you apply that and go OK, now we should be able to use the time browser again, and of course play it through. So now you can see the problem is our red area, this is where our chlorine is high, which is good, and our green areas are bad. So what we need to do is go back to concentration calculated and use this N button here, the invert. So now red is bad and green is good, which is what we're used to normally. So then you can go back to your time browser and play it through, and I'll just give you a minute or two to follow that around. And you can see that the red areas here are when the tanks start emptying, and the tanks are now emptying, and that's where you're getting your very low residuals. And the reason that's interesting is because obviously the water is remaining in the tank too long, and so that's why it's coming out with such a low residual, and we need to investigate that with an age run. Okay, so now that we've played that through, I think that's probably enough. But the point is, we need to investigate just how old the water is in these tanks to see why these residuals are so low. Okay, so to do that, we're going to do an age run. So back to the alternatives, but this time it's not a constituent. You can see that age has its own constituent. So we're just going to use default age as our alternative, so that's fine. And then open it up. So the age that we want to set initially, we need to firstly sort our labels. So I'm just going to right click, sort ascending to put them in order. And then all we want to do is we want to set an initial age of 1 for the first 19. So I'm going to go down from 1 to 19 there and just highlight them. And then global edit and set it to 1. So the reservoirs, of course, are going to be 0 because the reservoirs are pumping out fresh water. However, the tanks we need to give an initial age to because we need that. We need the calculation to be able to balance out the settling age, or to settle onto the correct age. So what we're going to do is we're going to take a bit of a guess here and put in 72 hours for both tanks. Of course, we'll find out whether that goes up or down once the simulation runs for a while. Okay, so that's all we need to do is just set the initial ages, which we've done, so you can close that down. And just like constituent, age needs its own set of calculation options. So up under home, calculation options, and another set of new ones, and I'm just going to name this age. And open up properties for age and change the calculation type to age. And then all we need to do is the same thing as last time, swap the duration over to 288. Okay, once you've done that, we need a scenario to put it into. So from base, take a new child called age. And when we open this up, we don't need to change the age alternative because we're just using the default age. So all we need to change is the solver. Okay, so once you've completed all of that, you can make it current and compute. Now, remember that what we did there was we put an initial age into the two tanks, but we basically guessed it. So we were just trying to guess what it might settle out as. And now we need to see if that's correct. So what I'm going to do is just highlight both tanks and then graph. And then down to your water quality results, age calculated. And if you OK that, you see that tank 2 here is continually going up. So it's up to between 130 and 140 there, but it's still trending upwards. So our initial guess of 72 was not very close for tank 2. You see that tank 1 here is right around 75 to 80. So what we need to do is take some better guesses around these starting concentrations. So for tank 1, I think probably around 80, and for tank 2 we can try 130. So close down the graph, go back to the alternatives and open up the age. And for tank 2, let's try 130, and we'll do 80 for tank 1. So this is something that takes a little bit of trial and error. You need to recompute it, of course. And then you can graph them and see if you got it right. So see that they're not perfect, but you can see that for the last week or so here, they're pretty flat. So we can be pretty confident that our age in tank 2 here is somewhere between 130 and 150, and our tank 1 age is somewhere between 70 and 90. So we've now settled out the initial calculation errors at the front here because of the other ages throughout the system, and you could go and update the rest of the ages throughout the system with these settled values if you wanted to get it perfect. But it's certainly giving you a very good indication of how old the water is in those two tanks, and you can see why the chlorine residual coming out of the tanks is so low when it takes 140 hours to turn over. So are there any questions regarding water quality? Because that is the end of the workshop.
Hello, thanks Tim. Hello, give me 1 minute.
Sure.
Dạ, các anh chị SAWACO, bạn Dean vừa kết thúc bài thực hành lớn đầu tiên về phân tích chất lượng nước. Chúng ta đã thực hành 3 lần chạy phân tích. Lần chạy phân tích thứ nhất làm cho TDS. Lần thứ hai là chúng ta làm cho dư lượng clo. Và lần thứ ba là chúng ta phân tích tuổi nước. Thì MiCat cuối tuần trước có gửi đến các anh chị bài tập và cũng như là tài liệu học. Thì các anh chị cũng nhận thấy là trong cái lần chạy thứ 3, tức là lần chạy phân tích tuổi nước, thì bạn Dean đã làm mở rộng hơn so với lại tài liệu chuẩn của Bentley. Đấy, các anh chị chú ý ở trong phần chat box của Teams thì MiCat có chép lại một số hình ảnh trên màn hình mà bạn Dean đã làm. Lần thứ nhất, sau khi chạy phân tích chất lượng và tuổi nước thì chúng ta có vẽ đồ thị cho tuổi nước tại hai bể T1 và T2. Chúng ta sẽ nhìn thấy ban đầu có hai giá trị đều là 72 giờ. Đấy là giá trị ước lượng mà bạn Dean đã nhập vào làm giá trị ban đầu cho tuổi nước của hai bể. Nhưng khi chạy phân tích xong thì chúng ta nhìn đồ thị thì thấy có một sự khác biệt rất rõ rệt giữa đồ thị tuổi của T1 và đồ thị tuổi của T2. Dựa trên kết quả đồ thị này thì bạn Dean đã chạy lại một lần thứ hai, tức là sửa lại tuổi ban đầu cho tuổi nước ở trong hai bể, không phải là 72 và 72 nữa, mà là 130 và 80. Sau đó chúng ta dùng lại những alternative, tức là những cái lựa chọn thay thế, cũng như những kịch bản và các calculation option, tức là các tùy chọn về tính toán mà ta đã thiết lập trước, và ta chạy lại lần thứ hai. Ở lần chạy thứ hai này, với giá trị tuổi nước ban đầu là 130 và 80 thì chúng ta có được đồ thị tuổi nước chính xác hơn và bình ổn hơn. Ít nhất thì kết quả của đồ thị này cũng cho ta biết về cái tình trạng chung ở tuổi nước ở trong bể cũng như trong toàn hệ thống. Tóm tắt lại là trong bài thực hành về tuổi nước thì chúng ta đã chạy 3 dạng phân tích, một dạng cho TDS, một dạng cho clo và cuối cùng là water age, tức là tuổi nước. Rồi bây giờ bạn đi, mong các anh các chị đặt câu hỏi ạ. Haydin, hello.
Yes.
There is a question.
Sure.
Yes. Ai hỏi đấy em? Haydin, hello.
Yes, I'm just reading it.
Okay, thank you.
Yeah, so if you calibrate the model for pressure and flow, it doesn't necessarily mean that it's also calibrated for the chlorine residual, and that's because you need to calibrate both things separately, including the wall reaction rate and the decay rate. So it may be that you need to redo some jar tests, or just bring in your as it mentions, Darwin Calibrator only does calibration for pipe roughness and demand. It doesn't automatically adjust your water quality parameters, so which means you kind of have to do it yourself as far as calibrating it. So that's with both your starting initial concentrations and the two negative values that we put in there. So you have to adjust those values and then recompute it and then test it against the values that you've brought in from the network. But as far as the age goes, how many hours is the age of the water? Well, that totally depends on your system. So if the age of the water is too old, the effect on water quality is it gets worse and worse as the water gets older and older. So you're going to have worse chlorine results, worse THM results, and pretty much all of your water quality results are going to be worse based on your water getting older and older. So there's no way to do that without calculating it in your particular model, and then recalculating it like we just did then until you get it to a point where the model is settled and all of your graphs have settled out. That's the only way you can tell.
Oh, Dean, this is a very long sentences. Okay, I would like to summarize.
Yes.
Before I repeat it in Vietnamese. Yes. Okay. As far as I understand, there are two kind of model. The first one is when Mr. Calvin have the calibration done for the model for flow and velocity. This is just the hydraulic model, right?
Yes.
He has also to do the second part, which means calibration for water quality.
Yes, this but a manual calibration, not using Darwin calibrator.
Okay. So first of all, it's hydraulic calibration. Okay. And he has to do first a manual calibration for water quality.
Yes.
Okay.
Manual in the sense that Darwin calibrator won't do it automatically, but it's not manual because SCADA Connect will bring in and show and graph the results of the field data. So it's only manual in terms of comparing the results and then adjusting them. Everything else will be done automatically.
Okay. So this means manual in comparing the parameter and graph and adjusting them, right?
Yes.
Yeah.
As well as jar tests.
Yeah. Okay. With the parameter for water quality. This is the first part, right?
So the hydraulic or the pressure and flow calibration, that's automatic using Darwin calibrator. That's the first step to anything.
Yeah. Okay. Okay. I will repeat it in Vietnamese and come back to you shortly. Okay?
Sure.
Yeah, thank you. Dạ, anh cảm ơn anh Cao Văn Tấn đã đặt câu hỏi với bạn Dean. Ở đây thì chúng tôi xin được phân tích câu hỏi rất là tổng quát của anh ra thành nhiều cái chủ đề con. Chủ đề thứ nhất, ở trong câu hỏi thứ nhất là trong câu văn thứ nhất là tôi đã từng cân chỉnh mô hình thủy lực hệ thống cấp nước SAWACO và nhận thấy tình huống mô hình sau khi cân chỉnh tương đối hợp lý về áp lực và lưu lượng. Nhưng khi chạy mô hình Chlorine thì thấy có rất nhiều sai số. Riêng câu ban đầu này ta sẽ chia ra làm hai bước ạ. Theo như bạn Dean nói ấy, thì khi chúng ta chạy về cân chỉnh hoặc là hiệu chỉnh mô hình về áp suất và lưu lượng, áp lực và lưu lượng thì đó mới là bước 1, tức là chúng ta hiệu chỉnh về mặt hydraulic, tức là chúng ta có được một cái mô hình thủy lực được hiệu chỉnh. Đấy là bước đầu tiên để bắt đầu. Sau đó chúng ta cần làm ngay bước thứ hai. Bước thứ hai này là hiệu chỉnh chuyên cho từng aspect, chuyên cho từng gọi là khía cạnh. Ở đây là khía cạnh chất lượng nước. Thì chúng ta sẽ phải có rất là nhiều những cái bước hiệu chỉnh gọi là bán thủ công. Bán thủ công ở đây có nghĩa là chúng ta sử dụng WaterGEMS để chạy hiệu chuẩn. Nhưng chúng ta sẽ phải thử với rất là nhiều bộ tham số. Và mỗi một lần sử dụng xong bộ tham số nào chạy thì chúng ta phân tích kết quả, chúng ta vẽ đồ thị và chúng ta so sánh những cái bộ kết quả với nhau để biết được cái cách mà chúng ta cần hiệu chuyển chương trình mô hình cho water quality, cụ thể ở đây là cho chlorine như thế nào. Hi Dean, hello, I'm back.
Yes.
Yeah, Okay. Now we focus on the second term, on the second part of the question, right? The first
the
step
age?
is, yeah, the first step is to calibration the hydraulic. The second step is to calibration the water quality.
Well, so not for age. So age can run independent of any other water quality. So the only thing with age is that it just needs to be run several times, so that the graphs have time to settle out with the correct initial values in the tank. So that's why you have to compute it, check the results, then update the
initial age, right?
Sorry?
You have adjusted, you have made a second run based on the adjusted initial age of the tank, right?
Yes, yes.
Yeah, and this is exactly the way you also recommend SAWACO engineering to do when they are dealing with water age.
Yes, absolutely.
Yeah, okay, yeah, thank you. Dạ, bạn Dean ở đây có trình bày trong cái lần chạy thứ 3, tức là run 3 để phân tích tuổi nước ấy, thì lần đầu là chúng ta lấy áng chừng tuổi nước đầu tiên, tức là tuổi nước khởi thủy ở trong 2 bể đều là 72 giờ. Nhưng đến khi chạy ra thì chúng ta vẽ graph, vẽ đồ thị ra thì chúng ta thấy kết quả nó không ổn và chúng ta cần phải chỉnh sửa lại cái tuổi ban đầu của trong 2 bể cho nó khác nhau và nó gần hiện thực hơn. Và trong lần chạy thứ 2 thì kết quả là đáng mừng hơn và nó khiến chúng ta có thể tự tin là chúng ta hiểu chuẩn được về khái niệm về khía cạnh tuổi nước. Vậy thì đối với câu hỏi của anh Cao Văn Tấn ở đây ấy, là bạn Đin cũng đề nghị là chúng ta sẽ, các anh các chị bên SAWACO cũng sẽ áp dụng theo cái quy trình này, tức là chúng ta ước lượng một số những cái tham số về tuổi nước ban đầu, chúng ta chạy và khi vẽ graph thấy không ổn thì chúng ta sẽ chỉnh sửa dần dần những cái tham số đó cho đến khi nào ta có được cái kết quả tương đối là convergent như là trong cái ví dụ ở đây. Yeah, hi Dean, I'm back.
Yes.
So, and the third part of the question is the effect of the water quality, right?
Yes.
And you mean that it will be worse and worse if we not calibrating it well, right?
It's just worse. The older the water, the worse it's going to get, because you're going to have to re-chlorinate the older water, which is going to result in THM problems and other problems as well. So, yeah, I think, it says if age of water is too old, what effect will it have on water quality? Well, it will have a very bad effect on all water quality parameters, including chlorine.
Yeah. Okay, thank you. Bạn Đin muốn nói là nếu tuổi nước mà quá cũ đấy, nó sẽ ảnh hưởng đến chất lượng nước cách trực tiếp. Nó ảnh hưởng rất xấu đến tất cả các tham số của chất lượng nước. Okay. We have a second question. Hi,
Sure.
Dean. Hello. Yeah.
Yeah, that's a good question. So the wall reaction order, or the wall reaction parameter, depends, of course, on your pipe system. So it depends on the diameter of the pipes that you're computing it on. Whereas, of course, the reaction order and the reaction rate, that's regardless of your wall. So that's just going to be your flat decay rate of your chlorine in the water, regardless of the pipe. So depending on whether you have small diameter or large diameter pipes, that will depend on which one is more important of the two parameters. Now, as far as is there an easy way to calculate the exact amount of chlorine that you need to inject? No, you would need to run multiple models with multiple different starting residuals to find your optimum there, because you're going to need to balance the reaction rates and the wall rates with your initial concentrations, and then find the balance there over multiple runs. There's no calculation in WaterGEMS that tells you at what rate you should inject chlorine.
Yeah, thanks, Dean. Give me just a minute. Yeah.
Sure.
Dạ, hello các anh các chị, bạn Dean muốn cảm ơn vì đây là một câu hỏi rất là tốt. Cho phần thứ nhất, ở đây chúng ta có hai parameter, một là Boole reaction và hai là wall reaction, có nghĩa là phản ứng số lượng lớn và của nước với nhau, của bản thân cái nước với nhau và phản ứng với vách thành với tường, the wall reaction. Câu trả lời của bạn ở đây là anh chị hỏi về trong ống, tức là trong pipe, trong đường ống, thì có một tham số rất quan trọng ở đây là đường kính của đường ống. Và tùy theo cái đường kính của đường ống thì lúc bấy giờ cái ảnh hưởng, tầm quan trọng hoặc là cái tầm ảnh hưởng của hai cái tham số này nó sẽ thay đổi. Nếu chúng ta muốn đảm bảo là cái lưu lượng dư lượng clo nó đảm bảo đủ tiêu chuẩn thì chắc chắn là vẫn phải tính rất là nhiều lần, dùng WaterGEMS tính rất nhiều mô hình với rất nhiều những cái bộ tham số khác nhau, và tùy theo cái độ lớn của mô hình, tùy theo độ lớn và cái điều kiện về tham số của đường ống cũng như điều kiện về tham số của nồng độ clo, thì các anh chị sẽ phải balance, tức là đạt được một cái thỏa thuận, một cái tổ hợp hài hòa giữa các tham số đó để có được cái giá trị ổn nhất cho cái chất lượng và dư lượng ở clo. Hydrant, hello.
Yes.
Yeah, I should repeat two aspects, two details. The first one is Boole reaction and wall reaction. It depends also on the diameter of the pipe, right?
Yes.
Yeah,
that's correct.
And the second one is we have to run multiple tests based on WaterGEMS. This means we have to run several models with several set of parameters. It's based also on concentration of color and also of parameter of the model itself, like the pipe.
Right. So if they're trying to find the optimal injection number, whether it's 1 or 2 or whatever, then they'll need to put in or guess a number, like start with 1 and then see whether or not their residuals are high enough. If they aren't, then they can increase it and then recompute and so on until they find the optimal. Because there's no tool in WaterGEMS that specifically optimizes injection rates, unfortunately.
Yeah, okay. So there is no optimize. We have to do is pair test and test.
Yeah, just change the number, then click compute, then change the number and click compute, and so on.
Yeah. Ok, chắc anh chị nắm rõ rồi ạ. Tức là chúng ta bắt đầu từ cái số lượng nhỏ và sau đó thì cứ tăng dần một cách có hệ thống và tính toán đi tính toán lại, rồi so sánh các kết quả với nhau để có được cái kết quả tối ưu, tức là các bộ tham số tối ưu của mình. Còn câu hỏi nào nữa không ạ? Anh chị còn câu hỏi nữa không ạ? Hydrant, we just wait maybe just 1 minute. If some
Sure.
more question come, yeah,
Sure.
yeah, we are asking SAWACO. Mm. Dạ, các anh chị còn câu hỏi nào nữa không ạ? Hi, Dean. Hello.
Yes.
We see no question more.
Okay. Well, let's take a 15-minute break.
Yeah.
And come back and we'll do the flushing. The next
flushing.
one on the list, which is 16, the flushing.
Yeah. Okay. So 15-minute break, and after that we will do flushing.
Yes.
Thank you very much. Mời các anh các chị nghỉ giải lao 15 phút ạ. Sau khi giải lao chúng ta quay lại, chúng ta sẽ làm đến lập chương trình xả nước là PDF số 16 là flushing. Thank you all. See you.
Flushing. So we're going to do two types of flushing here. So we're going to firstly do the base flushing, or just your standard flushing, and then after we've done that, we'll do one unidirectional flush where we'll close some valves and see if we can get a larger flow back the opposite way to the traditional base flushing, conventional flushing. Okay, so let me share my screen here. And close down the water quality, and then go ahead and open up from the same folder again, and this one's going to be flush work start. Okay. So you can see that there's some color coding on the network already. So if you check the element symbology, you see that we've got diameter there. What we want to do is create a color coding for after we've already run the flushing, so that it's already set up, so that we don't have to create it after. So what I'm going to do is untick diameter, and then on pipe I'm going to right click and say new color coding. And the field name I want is going to be velocity maximum flushing. So velocity maximum flushing. So if you calculate range here, nothing will happen because we don't have any results yet. So you just go and enter 5. So maximum, enter 4, 0 to 4. And then instead of just color, we're going to use color and size, and then initialize. So basically, we're looking for the larger red areas will be the ones that have the large flushing. Now, if you apply that and click OK, you can see that nothing's happened. Again, we don't have any results here. So we've set that up for after we've created and run our flushing study. Okay. Now what we can do is get started on our actual flushing. So if you go up to the analysis tab, and you'll find there's flushing. So go ahead and open flushing. Okay, so in the flushing study here, we want the representative scenario to be steady. All right, then we can click on our base flushing, and this is where we enter the values, very similar to fire flow, where we're going to enter the values for what we want in terms of flushing results as far as pass or fail, and so on. So the target velocity, the first one here, is 0.91 meters per second. And we're not going to include a shear stress. We just want the velocity, and then we can skip over those ones. We'll come back to those, and then down here in the adding to baseline demand, as you can see, the flowing emitter coefficient is going to be 12.04. The flowing demand 0, adding to baseline demand, that's fine. And then include nodes with pressure less than, and you want to tick that, and it's 206.8 kPa. All right, so back up to the pipe set area here. So in the pipe set, you can see that it's a collection of 0 items. So go to the ellipsis and then select from drawing. And what I'm going to do is just zoom out and draw a box around the whole lot. You could also go to query and network all pipes if you wanted. Either way, just select all pipes and then green tick for done. And you'll find that you've got 364 pipes in your count there. All right, so now we've set up our parameters as far as what we want to do with the flushing. Now we actually have to add our flushing elements, and they're going to be hydrants. Something to keep in mind, because I get this question quite a bit, what's the difference between a junction and a hydrant? Well, it's a trick question. There's no difference. So other than the icon being different as far as they look different in the drawing, you can flush a junction or you can flush a hydrant. It doesn't matter. So you do not have to have hydrants in your model in order to run a flushing study. If you only have junctions, that's absolutely fine. Okay, so on the base flushing here, I'm going to right click and say add. And I mentioned we're going to do the unidirectional second, but the first one, the conventional standard flushing, the batch, that's the one we want. And now it's asking me to select which elements I want to flush. I want to flush all hydrants. So I'm going to go to the query, network, all hydrants. See, it's now selected all the hydrants for me, so I can just green tick that. And you'll find that each individual hydrant in the model has a separate event created for it. And that means that we can flush them all at once as a batch, or you could go and do these individually if you wanted to and modify them one by one if you were particularly interested in a particular hydrant. Okay, so now that we've added all the hydrants, we're just going to go and modify one particular hydrant. So if you scroll down and highlight hydrant 91, and the reason that we want to highlight this one is because this has a larger diameter hydrant, which means we can specify a local flow with an emitter coefficient of 30.1. So a larger hydrant means a larger emitter coefficient. Okay, so scroll all the way back up to the top and highlight base flushing, because if you highlight base flushing, it'll do all of the events underneath it. that's what we want. So you can go and click compute. Okay. So once you've done that, you can close down your flushing and then look at your color coding here. And there you can see where various pipes have been flushed well or not so well. So the red ones are and the pink and the dark blue have flushed well. The green ones have not flushed very well. All right. So we can also check the reports the same way that we do in Fireflow. So go to flushing and see the flushing area report. You can check that one. And you can scroll through the results here and you can see that some of them are above the 0.91 that we need for the flushing, and of course some are below. And so that's this tick box here, satisfies flushing target or not, satisfies various things. So you can see the different diameters and so on. So that's a nice table as far as being able to sort that quickly. And might also want to, if you close that down, have a look at the flushing results browser as well. And you can see the hydrant discharge, which is a handy calculation to have. All these sort of parameters that you can review. Okay. Now what we want to do is have a look at our unidirectional flushing. So if you close that down and then just zoom in or find, and you can, if you go to the home tab, you can use the binoculars here to find element. And the element that we want is TL-107. So here's pipe TL-107, this one here. And you can see that it's going from left to right, the flow direction. So what we want to do is we want to use a unidirectional flush to send the water, to basically to get the result higher. So if you check the results here, if you scroll down to the flushing results, here you can see the results for this particular pipe. So the maximum flushing velocity here, 0.7. So I'm going to go to the element symbology here, and if we scroll down and find the isolation valve, see that the labels are ticked off. I'm going to tick the labels back on. So there you can see the various ISO labels up and down the model there. So there's ISO 212 and then ISO 85 up here, right along near our flushing target here. Okay, so now that we've sort of investigated this pipe, we're ready to go and run a unidirectional flush on it. So back to analysis and back to flushing. So if we go to the flushing study, you can right click and say add new study or new area. We want new area. And the area 1 down the bottom here, I'm going to rename that UDF, unidirectional flushing. So in the UDF, we'll just put the same values in, so 0.91, and then the flowing emitter coefficient again is 12.04. The include node pressure less than 206.8. And then just add the pipe set again. So again, select from drawing, and then I'm just going to go to network, all pipes. So it's the same as last time, 364. So the target velocity, flowing emitter coefficient, include nodes with pressure less than, and the pipe set. So I've basically just set it up the same as the first area. Okay. So now we can go down and right click on UDF and then say add a new unidirectional event. Sorry, we need to select the representative scenario first. The representative scenario is steady. Okay, so back down to UDF and right click and add a new unidirectional event. So now it's asking us to add pipe run elements. So the pipe run element that we want is, of course, the pipe that we just zoomed in on, which is this one here, TL107. And then we need to add operational elements as well. So that the next one along here in the select bar, as you can see, is add operational elements. So what we want to do is close two isolation valves, which is isolation valve 85 here. And if you scroll down a little bit, you'll also find 212 here. So 212 and 85 are closed. And then we need to have a flushing hydrant, which is hydrant 42 here. So we've just got the three elements, the two closed valves, and then the hydrant that we actually want to flush. And you see that the flow is going away from the hydrant currently. So green tick that. And with UDF selected, we'll go ahead and click compute. And then if you close it down, you can look at you can see the color coding has changed because we're only interested in this one particular pipe. And you can see that we have in fact increased the velocity through that pipe by closing those two valves. So it didn't necessarily increase dramatically. It's a long way away from the source, but it just gives you an example that you can go and do a unidirectional event like that. Okay, so if we go back to our flushing and then scroll down to the bottom in in our event 1 under our unidirectional flushing there, and just highlight event 1. What you can do is come up to the report tab, and you can see we've got several reports here that we can run. So what we want is the flushing area field report for unidirectional flush. Then you can look at the report. See, it tells you which valves to close, which hydrant is flowing, and you can see we've got a predicted pressure, a predicted flow here, and we've also got a minimum and recommended time for flushing it. So let's say 6 minutes, and you're going to lose 20,000 litres of water. So you can see that it's quite a effective report, because you get exact numbers on particularly how long to flush, as well as the volume of water you're going to lose. So you can keep track of the amount of water that you're going to lose for your flushing routines, which can be quite handy. Okay, so if you close down that report and then go back up to the top with the base flushing, you'll find that you can also grab a flushing area field report for base flushing as well. And you see that it will do every single hydrant for you. So you can see just how long this is, and you can print this off and send the guys in the field to do each of these flushing events. Okay, so any questions on flushing? Because that is the end of that fairly short workshop.
Dạ, bạn Điên vừa demo xong cái bài thực hành sử dụng tính năng trong WaterGEMS để tạo 2 lần xả. Một lần chúng ta là xả thông thường, và lần thứ hai thì chúng ta phát hiện ra nơi nào có vấn đề thì chúng ta sẽ xả một chiều. Các anh các chị có câu hỏi nào về tính năng lịch trình xả nước ở trong WaterGEMS không ạ? Các anh các chị có câu hỏi nào không ạ? Hi Dean, hello.
Yes.
We see no question coming.
Okay.
No question, yeah.
Okay, no problem. Shall we go on to a short workshop and then take a second break?
Yeah, it's up to you. Or should I ask the SAWACO engineer?
Yeah, maybe ask them. Yeah.
Okay. We will ask them. Bạn Điên muốn hỏi các anh chị bên SAWACO là bây giờ chúng ta làm thêm một workshop nữa, làm thêm một bài thực hành nữa cho một chủ đề khác, rồi chúng ta mới nghỉ được không ạ? Hay các anh các chị đề nghị nghỉ ngắn rồi quay lại sau? Mong các anh các chị cho ý kiến ạ. Hãy nghỉ không ạ? Hello?
Yes?
No, not yet. We got no answer. You just a moment. Mr. Calvinton recommend to go on. So.
Okay.
Rồi, cảm ơn anh Cao Văn Tấn ạ. Vậy là bây giờ mình làm luôn ạ. Làm luôn một workshop nữa rồi mới nghỉ đúng không ạ? Okay. So we go on for another workshop, please.
Sure, no worries. Yeah. Now, I believe we did the leak detection workshop in the last session, right?
You mean liquids, right? What do you mean?
So number 17, leakage detection. I believe we did that in the first session.
Yeah, we have done a little bit on leakage detection in the first training course. Yes.
Yeah, so that's the same one. So we won't do that again.
Okay. Okay.
So I think what we'll do is we'll go on to number 20, which is SCADA Connect, modeling a pipe response with SCADA Connect simulator. So we'll do that one because it's relatively short, and then we can have a break, and then we can do number 18, which is setting up the SCADA signals, which I think will be a good one to do last, as it's I guess more in depth, but also it will be fresh in the mind, so that
yeah. Okay. So we don't do again the leakage. We go now to 20, right?
20, yes.
Yeah, and after break we will do SCADA again, but with 18 and 19 for more details, deeply, right?
Yeah. So 19 and 20 are very similar, so we'll see how we're going for time. But we'll definitely do 20 and then 18, and then we'll see how the time is for number 19.
Okay. So we do now the 20, right?
Yeah.
And after break we will do 18, right?
Correct. Yes.
Yeah. Give me 1 minute. Yeah. Okay. Dạ, bạn Linh muốn nhắn với các anh chị SAWACO là lần trước trong cái training course vào tháng 5 ấy, chúng ta đã đề cập đến vấn đề phát hiện rò rỉ rồi. Cho nên lần này chúng ta sẽ bỏ qua cái bài 17. Bây giờ chúng ta làm bài 20. Bài 20 này là chúng ta kết hợp WaterGEMS với các tín hiệu của hệ thống SCADA nhằm mục đích là phân tích những cái sự cố vỡ ống và vấn đề vỡ ống nói chung. Sau khi làm xong bài 20 này thì chúng ta sẽ nghỉ ngắn, và sau khi nghỉ ngắn thì chúng ta quay lại, chúng ta sẽ làm bài 18. Bài 18 thì cũng là quay xoay quanh chủ đề SCADA nhưng sẽ chi tiết hơn và sẽ có nhiều thiết lập cần thiết hơn. Bây giờ cho chủ đề của bài 20 thì mong các anh các chị đọc ngắn cái phần nội dung tóm tắt mà Miket vừa mới posting lên trên chatbox của Microsoft Teams. Và nếu được thì cũng mong các anh các chị mở cái PDF số 20 bằng tiếng Việt mà Miket đã gửi vào thứ 6 tuần trước ạ. Okay, Dean? We are okay to go.
Okay. No worries. So we close that one down, and then open up, and this one's going to be called brake valves, SCADA sim start. Brake valves, SCADA sim start. Okay, so see, I've got a network here which is quite complicated, and what we're going to do is go and test how the system is performing firstly. Then we'll go and add a pipe break to it, and we'll find out what would happen to our system with that pipe break, and then more importantly, we will fix the system as far as the pipe break, because we don't want any tanks running out of water or anything like that because of a pipe break. So this is an operation style investigation. So the first thing we need to do is go to EPS 24. You can see it's already made current, and then click compute. And you can see we've got a problem here. The tank control is I believe it's tank 4. It's tank 4. Maybe tank 7. Let me check. Yeah. So if you open up the properties of tank 7 and then change the base elevation to 100 and the level maximum to 7. And then recompute. So just to repeat, that was tank 7, and you need to change 2 elevations, the base and the maximum. Okay. So once we've fixed it up and we know that we can run the model correctly, we can go to the analysis tab again, and right over here on the right hand side you'll find SCADA Connect Simulator. Open up SCADA Connect Simulator. One of the nice things about SCADA Connect Simulator is that you can do pretty much everything from right inside this dialog box here. So you don't need to do anything and then close it down and then view the results and then open it back up and so on. We can do all of that from within this particular dialog box. So what we can do firstly is just compute. And then close down your calculation summary. All I want to do is, and of course we haven't put any controls or pipe breaks or anything on. You can see that they're all ticked on, but there's not actually any events here. These are just the headings. Same with these. There's nothing underneath these. So this is just a standard run. So we can check how the system is operating as a standard run with no pipe breaks. And so to do that, we can click on the graphs. And the one that I'm interested in is all tanks. So you can just have a bit of a look at this graph for a minute here, but the main thing to notice is that none of the graphs, none of the levels go below 30%. So you can see that they're all above 30% for the entire simulation. You can see that this red one here gets down to 32% or so, but most of the other ones are up above 45 or above 50 the whole time. So basically what we're trying to note is that the tanks are very full all day. Obviously to have spare capacity in case there's some sort of emergency. Okay, so now that we've looked at our tanks, we're happy with that. What we can do is add our pipe break. So over to emergency response, and of course we want a pipe break response. So if you zoom down to the bottom area here, you can see that there's the main pump station, so reservoir 3 pumps, and then along that line you'll see there's this little box. It's just a little drawn in box, and that's where our pipe break is. So I'm going to click right on that, and it's going to insert the pipe break right on there. Okay, so the pipe break it starts on that date at 2 a.m. and it has a leakage flow of 10 litres per second. Of course, we need to isolate the break, so tick isolate break. The problem is the break occurred at 2 a.m. but the crew doesn't get there until 3 a.m. So you need to change the start time of the break isolation to 3 a.m. and then it's 5 hours until it's fixed. So it takes them 1 hour to get there, 5 hours to fix. We can also isolate the break. So if you click isolate break, and I'll just move that dialog over, you can see it's put the break in here with the symbol. Then you can see we've got valves around the break here. So we need to auto isolate the break. So just click auto isolate, and you can see that it's highlighted and closed 4 valves for us, so that we can directly go and drain and fix the pipe break while not affecting the rest of the system here. So done automatically for you by WaterGEMS. Okay, so click OK, and then OK, and you'll see that if you move the dialog, you'll see there's your isolated valves as well as your pipe break there. Okay, so compute. You see now, instead of all greens, we now have some yellow messages, and of course the system disconnected because of pipe break. So that's clearly an expected message. So because we put the pipe break in, so that's fine. And what we're interested in, of course, is our tank levels. So back to the home tab, graphs. So all tanks, and you can see what's happened here is that the brown tank, which is tank 1, has drained in order to make the slack where the pipe break is shut down that particular reservoir and pump station. So you can see it's down here, down to about 15% or about 17%, and that's not what we want, because tank 1 is too important. So we don't want to drain tank 1 down to 17% there. Okay, so how do we fix it so that tank 1 does not drain down to 15%? Well, we put in control overrides. All right, so this is the control overrides are really the most powerful feature of SCADA Connect. So in the control overrides here, I'm going to right click and say edit. So what we need to do is create a new one, and then it's going to ask you to select from the drawing the various elements that you want to add to your control overrides. And we want pump 5, 6, 7, 8, 9, 10, 11. So pump 4 to 11. So if you zoom in, you can select pump 4, and then new, pump 5, and so on, and then 6, 7. So I'll just give you a minute and then go all the way up to to 11. I'll just give you a minute or two to to go and select those 8 pumps. Okay, well, hopefully you've added all 8 pumps, and now we can go and fill out the rest of it. So the pump element type, pump status, and then you need to change them to off. So you can see the start time here is 2 a.m. I want to global edit that and select 3 a.m. Global edit, select 3 a.m. And the same thing with the duration. We want to global edit, set that to 5 hours. So basically, we're turning all of those pumps off for the full 5-hour duration of the shutdown. Okay, so click OK, and then compute. And now you can see we have red errors. And if you click on the red error, you see that the system is disconnected, the network's unbalanced. And if we have a look at our graphs, we'll find out why. So again, graph all tanks, and you can see why. You can see that tank 4 here has completely drained, and it's now empty, which has caused the system to disconnect because it's out of water. It has no network connectivity anymore, and is now causing errors. See that various junctions are disconnected from reservoirs or tanks. They're out of water, so we can't have our tank getting down to 0%, of course. Okay, so let's go and see if we can fix it. So I'm going to close that down and go back to my control overrides and edit. And what we want to do is we want to go with pump 6 and pump 8. So firstly, pump 6, I'm going to change its duration to 3 hours. And the same with pump 8. So I've changed pump 6 and pump 8 back to 3 hours of shutdown instead of 5. So if you click OK on that, and of course compute it, no red errors this time, and check your graphs. So now you can see we've got our blue tank, tank 6, gets down to about 10%, 8%. However, the other ones do not, and we don't have tank 1 dipping below 15%. So we've just moved some water around from various tanks in order to spread the load a bit for the system being disconnected because of a pipe break. And there's many other options in there that you could have gone with as well. So as far as turning pumps or valves or whatever on or off, so you can add control overrides to anything. So that's why it's such a powerful tool, because you can investigate operational scenarios very, very quickly and easily. As I said, that one's a pretty quick workshop, so that is the end of the workshop. So if there's any questions, let me know, but keep in mind that the workshop we'll do after the break is how to set up SCADA Connect from scratch, and that's a much longer and more in-depth workshop. So if you're wondering how to set up SCADA Connect and SCADA Connect Simulator, we'll take care of that within the next workshop.
Dạ, chào các anh, các chị. SAWACO, bạn Dean vừa hoàn tất cái bài demo về phân tích mô phỏng một cái sự cố vỡ ống. Các anh, các chị có câu hỏi nào về bài vừa rồi không ạ? Bạn có nhấn mạnh lại là chúng ta nhìn thấy ở đây là công cụ trong WaterGEMS cho phép chúng ta tìm hiểu rất là nhanh chóng và dễ dàng các kịch bản vận hành khác nhau. Chúng ta có thể tắt rồi mở rồi thay đổi tham số của từng máy bơm và rất nhanh chóng nhìn thấy cái kết quả được thể hiện bằng đồ thị của các bể. Bài 18 sau cái lần nghỉ ngắn này của chúng ta nó sẽ liên quan đến vấn đề là thiết lập SCADA. Đây là một bài khó và đòi hỏi nhiều công sức và cũng lâu hơn. Bạn Đin rất là mong muốn các anh chị nếu có câu hỏi nào về cái bài vừa rồi đấy thì chúng ta nêu lên ngay bây giờ để chúng ta xử lý cho rốt ráo vấn đề này ạ. Các anh chị còn câu hỏi về bài 20 không ạ? Ai có câu hỏi về bài 20 không ạ? Nếu có câu hỏi nào mà các anh chị chưa tiện nêu lên trong ngay bây giờ, trong thời gian này thì bất kỳ lúc nào các anh chị cũng có thể nhắn qua Zalo hoặc là gửi email dùm đến cho Miket ạ. Để vậy nếu bây giờ không có câu hỏi nào ngay lập tức bây giờ thì chúng ta sẽ đề nghị bạn Đin là cùng nghỉ ngắn và quay trở lại để làm bài 18 sau. Bạn Đin muốn nhắn rằng là thật sự nếu ai muốn làm thật sự đấy thì có lẽ các anh các chị chuẩn bị tư tưởng cùng làm bài 18 với lại bạn sau cái lần nghỉ ngắn này. Hi Dean, hello. I see no question. Maybe you made we made the break now.
Yes.
Yeah, 15 minutes.
Take a bit longer if you
okay.
like.
Okay.
Back at 11:30.
11:30. Yes. As you wish. Yes. Okay. So see you in 11:30. Yep. Thank you so much. Yeah. Mời các chị nghỉ 32 phút ạ. Chúng ta sẽ gặp lại nhau vào lúc 11:30 và chuẩn bị cho bài 18. Cảm ơn tất cả mọi người. So nice cafe break.
The one that we want is SCADA signals start. So what we're going to do here is we're taking a normal model here that doesn't have any SCADA elements in it, and then we're going to assign them, and then we'll get the signals and we'll assign the signals to the elements. So quite a bit of setup initially here. Okay. All right. So to get started, what we're going to do is lay out the SCADA elements. So we need to find the Wi-Fi signal here is the SCADA element. So you can just follow me, but basically what we want to do is place the first two up on top of pump 1. So scatter element 1 and 2. And then down below pump 2 will be scatter element pump 3 and 4. And then if you pan over to the booster pump station here, we've got boost 1 and boost 2. So scatter element 5 and scatter element 6 on top of boost 1. And then the same thing down the bottom, scatter element 7, scatter element 8. And you can see we've got over to the right the high tank here. So the high tank will be scatter element 9. And then scroll up, you see there's two other tanks, east and west tank here. So west tank firstly, that's scatter element 10. And then the last one, east tank scatter element 11. Okay, so if you right click and say done, or go back to the select toolbar or whatever, all we need to do is open up the properties, and you can see that in the model element here it says none. So what you need to do is select model element and then select the pump that it's closest to. So go ahead and select each one for each pump that you need to assign. So I'll just give you another minute or two to assign all 11 scatter elements. All right, hopefully everybody's completed the assigning. So if you go back to the Home tab, you can go to the Flex tables and open up the scatter element table. And you see here we've got each of the model elements, pump 1, pump 2, and so on. So all we need to do is assign the field for the pump. So the first one here, you can see is flow. And then the second one for each pump will be pump status. So each pump has a flow and a status. So you need to do that for each one. And then each of the tanks is a level. So again, I'll just give you a minute to complete that.
Yeah, okay. Give us a minute to
Sure.
finish the table. Yeah. Yeah. Hi, Dean.
Yes.
Go on. Yeah.
Okay. So once you've filled out the field there, you can, of course, in the historical signal there's nothing there because we haven't set up the connection to the actual SCADA yet. So let's close that down, and now we can configure our actual connection to the SCADA. So if you go to the analysis tab, and then in the SCADA simulator drop down, you'll find SCADA signals. So once you've opened up SCADA signals, go to the new, and we want database source. Now, something important to note here, we're using an Excel sheet because this is a workshop that everybody needs to be able to do, and Bentley does not have a working SCADA system. We don't have a water network, so we don't have a real SCADA server to connect to as far as running it live. So we just use Excel as an example, but ideally you would connect directly to your SCADA server. So while this is an example of how to set it up, it's not the example that you would probably use to do it, because if you were doing it properly in your real model, then you could connect directly to your SCADA server rather than an Excel sheet. Okay, so the database source here and the connection. If we go to edit, the data source type here that we want is Excel, as I said. So Excel 12.0, and then the data source. If you click the ellipsis in this data folder, you'll see historical data there. Historical data is the one we're looking for. You go ahead and open historical data. If you would like, you can click test connection. Hopefully connection succeeded. And then click OK. So the table name that we want is 1st of October 15 history. And it's multiple row values per row. Now down the bottom in the options, we need to tick historical for our obviously our historical spreadsheet here, rather than a real-time connection will need to be connected to the actual SCADA server in order to get real-time. So historical there. Once you've selected that, make sure you select the timestamp as time in hours, and then select SCADA signals. So this is asking us which ones do we want to use. Now I'm going to go to the top double arrow and go add all. However, we don't need pH and we don't need turbidity. So I'm going to remove pH and turbidity. Now those are water quality fields, and you can include them if you want. It's just that in this particular example we're not including them, but you certainly can. Okay, so go ahead and click OK. Once you've set all that up, you can click OK again, and you should now have some data here. And if you click on any one of these and then click refresh, you should see some data has come in. So you can just go through the list and have a look and see if there's any values in there. So there's your pump 1 flow and so on. Okay, so once that's done, go OK. And now we have the signals available to match up with our SCADA elements that we've already placed and assigned. So back to flex tables, back to SCADA element. And this is where you need to go and grab the drop down and match up the field. So pump 1 flow. So I need to find pump 1 flow, and then obviously pump 1 status, and so on. So you need to go down the list and match up each signal to its corresponding historical signal. So I'll just give you a minute there.
Yeah, sure, thanks. Bạn nên chờ một phút để các chị hoàn tất bảng. Chọn cái element cho từng tín hiệu một ạ. Okay, Dean, please go on.
Okay, so you can see over in the historical signal value display, you can see that all of our levels have come in and our flows have all come in. However, the pump statuses have not. You can see that they're not available. So we've got a problem with our pump status. So obviously we need to fix that. So if you close back down your flex table, go back to SCADA Connect Simulator and back to SCADA Signals. And then double click on data source 1 to open back up the properties of it. And then go over to the signal value mappings tab. So what we need to do here is tell it what the SCADA system records it as, and then what we want it to tell WaterGEMS to do. So first, we want to go from no mapping to single value. And you can see that on equals on, off, we go equals off. So basically what we're saying is the text string that's going to be a result within the SCADA server is going to be on or off, and we're just going to map that to on or off in WaterGEMS. Now, this could be 1 and 0, or it could be open and closed, or there could be any number of codes that could be used for on or off. So you need to know what the SCADA server records it as, and then map the values accordingly. Okay, so if you click OK there, and then go back to your signals here and go to one of your statuses and refresh, and you can see that we now have statuses coming in correctly.
Okay, không?
Okay, so now that that's working, you can click OK. And with EPS normal here, I'm going to compute it. So I'm going to zoom into pump 1 here, and I'm going to go to SCADA element 1, the flow. And if you just click on the SCADA element itself and then click graph and OK that, you'll see that what happens is it automatically graphs both the SCADA signal and the model signal. So you can see how well it's actually representing the real world element out there in the field, the pump on and off, and you can check any of them. So you might want to check the tank. So I'll check the tank level. Again, you can see whether or not it's matching up correctly with the real world results. Something to keep in mind as well is that with these SCADA elements, you can also go to element symbology and find your SCADA element. And what you can do is in here you can add an annotation or a color coding to it, which means you can place annotations on there for real-time signals, which means that you can actually get the updated the tank level or pump status on off or flows through various elements right here, displayed right here on your WaterGEMS window. And they can just update, and you can alarm those and things. So there's a lot you can do with SCADA Connect once you've got it set up. So that is the end of that workshop. Any questions on the setup of SCADA Connect?
Bạn In vừa hoàn thành cái phần đầu của bài 18 là chúng ta kết nối lịch sử SCADA vào trong chương trình. Về phần cuối thì bạn có muốn nhấn mạnh với các anh chị là nếu chúng ta sử dụng cửa sổ Element Symbology, có nghĩa là biểu tượng của Phật tử, chúng ta có thể viết nhãn, chúng ta có thể viết ghi chú, và qua đó thì chúng ta rất dễ nhìn thấy kết quả hiển thị của tín hiệu SCADA trong thời gian thực trong cái mô hình WaterGEMS của chúng ta. Bây giờ bạn đi xin hỏi là các anh chị bên SAWACO có câu hỏi nào về bài 18 không ạ? Có ai có câu hỏi về bài 18 không ạ? Hydrant, hello.
Yes.
We see no question. No question. Yeah.
Okay. No worries. Well, that is the last workshop I had listed to complete. So as I mentioned, there are other workshops in the list there, but Scalabrator is a very specific tool for if you want to take a WaterGEMS model and convert it into a Bentley Hammer model. So that's not really applicable. And as I said, the 19th SCADA one there, that's almost identical to the one that we did before the break, which was number 20. So other than that, because we've already completed the leak detection last time, that's all of the advanced workshops.
Yeah. Thưa các anh chị, là trong danh sách chúng ta có tất cả là 11 PDF. Nhưng mà bài số 10 là Calibration ấy, là một cái công cụ rất là đặc biệt. Ví dụ như dành cho những người mua phần mềm WaterGEMS hạn chế ở số lượng ống. Ví dụ như chỉ là 2.000 ống thôi, nhưng muốn xử lý một cái mô hình có đến 3.000 ống chẳng hạn, thì chúng ta cần phải làm gầy cái mô hình đó để mà đủ điều kiện về số lượng ống, đủ nhỏ để thích hợp với lại cái phần mềm WaterGEMS mà chúng ta mua. Trong trường hợp của SAWACO ấy, thì là từ xưa đến nay là bên SAWACO đã định mua ở cái mức cao nhất là mức Unlimited Pipe, cho nên bài Calibration thì trước mắt là chúng ta hầu như không cần đến. Đấy, bài 17 là bài phát hiện rò rỉ thì chúng ta đã làm từ lần trước rồi. Bài 19 thì rất là gần như giống với cái bài 20 mà chúng ta đã làm trước giờ nghỉ. Đấy. Vậy để tổng kết lại thì bài 18 vừa rồi là bài workshop, bài thực hành cuối cùng mà bạn in chuẩn bị cho cái đợt huấn luyện với lại SAWACO lần này. Vậy bây giờ tổng kết lại, các anh các chị có câu hỏi nào chung cho tổng thể lần học thứ 2 này không ạ? Hoặc có vấn đề nào cần phải mở rộng? Hoặc có số lượng nào về dữ liệu cụ thể nào mà cần phải thẩm định? Hoặc là cần một lời tư vấn? Hoặc cần một cái phương pháp áp dụng cụ thể? Mong anh chị cho biết ạ. Có không em? Hi Dean, hello.
Yes.
I just repeat the summary you did in Vietnamese and asking for question, but we don't see any question coming in the chat box.
Okay, sure. Yeah, I mean, I'm happy to wait and see if there's any questions. It doesn't have to be about the workshop. Yeah, because this this will be the finish of the training today. So any questions about anything, please send them through. Otherwise, we can finish up and everybody can go home early. Yes. Okay. We will do. If any question, we will transfer to you immediately. Sure. Yeah. Okay. We're going to keep in touch with the SALO group, with SAWACO engineer, and every question, if any comment, we will let you know, send directly to you immediately. Okay. Thank you so much for the 2 days of training. It's an honor for my team to assist you. And Mr. Darius, thank you so very much for organizing this. Hello? Yeah. Okay. Thank you for all your help. Thank you. Before and during, and thank you everybody for coming and attending. Yeah, cảm ơn các anh các chị đã dành thời gian tham dự workshop trong 2 ngày vừa qua. Có câu hỏi nào như đã nói, mong anh chị cho Miket được biết và chúng ta sẽ cố gắng nhờ sự hỗ trợ của Bentley để giải quyết các vấn đề kỹ thuật. Thank you.
everybody. Have a nice day.
Okay. Bye, everybody.
Bye. Thanks, Dan. Thank you.